Okay, today we're going to work on standards EE3 and EE4, which is scientific notation. On page 8, we have number 1. We're going to write this number in scientific notation. We're going to talk about this for a second before we write it down. Just read for a minute with me. We want the number out front to be between 1 and 10. It's a one-digit number. It's got to be between 1 and 10. So we're going to have to move this decimal until we get a number between 1 and 10. And also, the number here is smaller than 1, so we know that when we have an exponent, it's going to be negative. All right, now take a second, write that down. Pause the video. All right, now we're going to do it. All right, find your decimal right here. We're going to move this until we get a number between 1 and 10. All right, keep going, keep going, keep going. Okay, I did a little loop so we can count how many. Be careful when you do your loops. Make sure you're going only around one number as you go. So it looks like I moved this decimal 5 times before I got the number 3. Okay, so what did I do? I moved the decimal 5 times, so I know my exponent's going to be -5. Take a minute, write that down. And then we're going to rewrite this number in scientific notation. So now we have a 3.21. And then don't forget, scientific notation is times 10 to some power. And the power is going to be a -5 for the reasons below. All right, number 2. We want to write this in standard form. All right, so the exponent here is positive, so the number itself is going to be bigger than 1. When we change it to standard form, it's going to be bigger than 1. We're going to move the decimal 3 times to the right, making it bigger. Pause the video, write that down. And now let's do it. We need to take our decimal, which starts right here, and we're going to move it 3 times to the right, around numbers 4, 5, and 6. All right, that leaves me with 2, 4, 5, 6, then a decimal point, and a 7. You can write the zeros down at the end, but you don't need to. So I'm going to stop right there. That is our number in standard form. A second. Circle that one too. All right, number 3. How much larger is 8 times 10 to the 6th compared to 2 times 10 to the 4th? Well, how much larger? What operation does that mean to you? Why don't you think about it as how much larger is just the number 8 than the number 2? How much larger is 8 than 2? To me, that's 6. 6 numbers larger. So what did you do to get from 8 to 2? We subtracted. Okay, so what we're going to do here is subtraction. This really means 8 times 10 to the 6th power minus 2 times 10 to the 4th power. So when we subtract, we're going to change them to standard form. Yes, there's another way to do it, but for now we're going to change to standard form. Wherever I write something down, please write it there as well. All right, so this first number, 8 times 10 to the 6th power, well, the 6 means I'm going to move the decimal 6 times to the right, leaving me with 6 zeros after the 8. So this becomes 8 with 1, 2, 3, 4, 5, 6 zeros. And 2 times 10 to the 4th power, I'm going to put it down here because we're going to subtract the 2. Well, With a 10 to the 4th power, that's going to leave us with 4 zeros. And I, of course, want to line up my decimals. Right now, the decimal on this one is right here. So if I line up the decimal here, I want 1, 2, 3, 4 zeros, line them up very carefully, and then a 2 here. And then I subtract. I get 0, 0, 0, 0. I can't subtract 2 from 0, so I need to borrow here, making this, well, this is going to be a 7, this is going to end up being a 9, and this one's going to be a 10, so that I can subtract. So 10 minus 2 is 8, and we have a 9 and a 7. So right now we have the number, let's see, just commas here so we can read it carefully. We have 7,980,000. But of course they want the answer in scientific notation. So now we're going to change this back to scientific notation. Let me rewrite it here. Right now the decimal's here. I want to move the decimal until I get a number between 1 and 10. So I'm obviously moving it to the left. 1, 2, 3, 4, 5, 6 times, giving me a number 7.98, which is between 1 and 10. So 7.98 times 10 to the, well, I moved it 1, 2, 3, 4, 5, 6 times, and it's a big number, so it's a positive 6. And you can write this here. We changed back to scientific notation. Okay, number 4. Which is larger, 3 times 10 to the 9th power or 9.9 times 10 to the 8th power? Well, here we want to look at the exponents. Okay, so circle your exponents. This one is a 9, this one is an 8. So we're looking at the exponent. The bigger the exponent, the bigger the number. Take a second, pause the video, and write that down. All right, so having written that down, which one do you think is the bigger number? It is 3 times 10 to the 9th power. That really means 3 with 9 zeros. All right, the next page, page 9, we are going to write this in scientific notation. What operation is this? Hopefully you know that that is division. We are first going to divide the numbers out front. Okay, when we divide those numbers out front, well, this is actually an easy one. We're going to write it here so we know what we're doing. We're dividing 4.2 by 2.1. We're going to do that in a minute. We're also going to divide our powers, which is different than dividing just regular numbers. We're going to take 10 to the negative 5th power divided by 10 to the 3rd power. And of course, this is still being multiplied to that. So let's see. When I divide this, can you tell that 2.1 is just half of 4.2? If you need to on the side, you can do your 2.1 into 4.2. Remember, top dog goes in the house. We'll move our decimals. So this is really 21 into 42, and that goes exactly twice. So that's why I said this one is easy. 2 times 21 is 42. So that became 2. And then when we divide our powers, I'm going to write it down step by step so you see what I'm doing. It is keep your base of 10 and subtract your exponent. Start with the top minus the bottom, so minus a 3. And of course that's going to give us, let's keep our 2 out front, 2, I'm going to write times 10. All right, negative 5 minus 3 gives us negative 8. 2 times 10 to the negative 8th power. If you'd rather write it with an X here, that's fine, you can do that too. All right, the next one we are going to multiply, and of course leave our answer in scientific notation. So we're going to multiply our numbers that are not powers. The only power I have is this one. So what I'm going to multiply are these two things together. And I'm going to do that on the side over here. So 3.1 times 0.003. Well, let's see. Let's do 3 times 1, I get 3. 3 times 3 is 9. Okay, and all the rest are going to be zeros because 0 times anything is 0. Now we have to count up our decimals. I have 1 here, 2, 3, 4, which means I need to move the decimal from here 4 times to the left. 1, 2, 3, 4. So the answer for that, these two together, is 0.0093. And since there's nothing to multiply our 10 to the 5th power to, it's just times 10 to the 5th. But the difference between this one and number 1, notice number 1 already had the coefficient between 1 and 10. Right now, our coefficient, our number up front, is not between 1 and 10, which means we need to move the decimal now. All right, if we move the decimal, we have to go, it's right here, 1, 2, 3 times, making it bigger. So this is now 9.3. Since I made it bigger by 3, I need to make my power of 10 smaller by 3. So instead of just 10 to the 5th, I need to make it smaller by 3. So this ends up being 9.3 times 10 to the, well, 5 minus 3 is 2. Second power. Don't forget the number out front has to be between 1 and 10. Okay. Number 3, you have 100,000 quarters. Each quarter is 1.5 millimeters thick. How tall is your stack of quarters? Write your answer in scientific notation in terms of meters. Oh, so not only are we going from millimeters to meters, but we also have to figure out what operation we have to do. This each is a key word. If you have 100,000 quarters and each is 1.5 millimeters thick and you want to stack them all up, you're going to multiply. Okay? Remember, whatever I write down, you write down. If I circle it, you circle it. All right, so we're going to multiply these things out. So we have 100,000 times, we'll use parentheses because I don't like to use X for times usually, times 1.5 is going to be 150,000. Okay, so that's 150,000 millimeters. We haven't really talked about this year, but we have to change it to meters. And you have to know how many meters are in a millimeter or vice versa. So my little trick is, this is how I remember this. We have K, H, D, M, D, C, M. And those stand for millimeters, centimeters, decimeters, meters, this is decameters, hectometers, and kilometers. Okay, those are all the different types of meters we could have. And the way I remember these letters is King Henry's drunken mother drinks chocolate milk. You might have heard it in a different fashion. There's lots of different mnemonic devices for that. But again, King Henry's drunken mother drinks chocolate milk. All right, if we want to go from this millimeters to meters, what do I need to do? Well, I need to move the decimal 1, 2, 3 times to the left. So from my original number, 150,000, I'm not going to put the comma in there, 100, well, yeah, that's it, 150,000. I need to take the decimal where it is right here and move it 3 times to the left to change it to meters. Okay, this will be now in meters when I do that. So 1, 2, 3 times there. So this answer is 150 meters. One last step though, they want it in scientific notation. So if we take this decimal now and move it so that the number's between 1 and 10, lots of steps to this one. This is going to be 1.5 times 10. Well, I moved it twice and it was a bigger number than 1. That's a positive 2. There you go. Well, we had a tricky one there, but now we have a much easier problem. Number 4, is this true or false? Does this equal this? Well, maybe some of you have seen this on your calculator, and that's where this comes from. This E just stands for scientific notation. So if there's an E there and there's a positive 4 after it, that means it's 3.27 times 10. That's what that E stands for, is the times 10. Times 10 to the, well, positive 4 power. Okay, is that the same as this? No, because that says a negative 4. And that is different than a positive 4. So the answer is false.